Hey guys, I'm Deepali Agarwal and welcome back to my YouTube channel ForMyScholars. In the last video, we discussed the implementation of queue using arrays. Now we will see this using linked list. So let's get started. One more important thing, now you can join us on our Telegram channel where you will get the notes of data structures, placement preparation material and gate related questions. You will get the link to join us in description box below. So now let's get started with the video. So before proceeding further, I would like to tell you something very important. If you are a student or a working professional who is looking for a great career in software development, then you have to think about aspects like what's trendy in the industry, what kind of questions are asked in the interviews, what's the thought process behind the architecture of great applications, how to improve your CodeChef ranking. If you are interested in all of this, then an academy is providing you a platform where you will get all of this. Our hosts are working with some of the top companies like Google, Amazon, to name a few. There are 7-star coders on CodeChef and are industry experts with years of experience. In live episodes, you get an opportunity to ask tech HRs about top 20 questions asked in industries, and also you get your resume and your college personal projects improved by getting them reviewed by expert SDEs. Participate in mock interviews and learn courses on programming languages, cloud computing, blockchain, crypto, tech aspects of digital marketing, data analytics and many more. So you can join me in these live shows every Saturday, Sunday at 10 p.m. in which I used to talk to the employees of different big tech companies. They share their life journey, how they improve themselves, how they build their programming logics and how upskills themselves. So if you are interested in such type of live shows, what you exactly have to do, you have to open this link. It's given in description box below. Now click on login, enter your mobile number. You will get an OTP at your mobile number. Just enter that. And now you will see, let's just click on get subscription. You will see the subscription is available for $9.99. What you have to do, you just have to enter my code, that is Deepali10. You will get it for $8.99. So when we talk about the implementation of queue using linked list, also we will see the implementation of all these functions: underflow condition, overflow condition, enqueue function, dequeue function and display function. So first let's talk about the basic structure of a queue when we are implementing it using linked list. So here generally what happens in case of linked list, there exists a pointer named head and some nodes, okay, like this. But in case of queue, when we are implementing a queue using linked list, we will use two pointers, that is front and rear. Okay, front will point to the first node of the linked list, or you can say front will point to the first node of the queue and rear will point to the last node of the queue. We already have learned the basics of queue. Front points to which number and rear points to which number or which element of the queue. We already have covered that in the previous videos. If you have not any idea about it, you can just check out the videos. Link to playlist of data structures is given in description box below. Okay, so now first let's talk about the underflow condition. Okay, underflow condition means when there exists no element in the queue, and if we are trying to delete some data from the queue, then first we will have to check the underflow condition, because if there is no element in the queue and still we are trying to delete something, it will create an exception. So first we will have to check for underflow condition. If there is underflow condition, we will not delete any data from the queue, and if there exists some data, some elements in the queue, then we will proceed to further. Okay. In the same way, overflow condition means when the size of the queue is full. But in case of linked list, there is no limit, there is no constraint on size. But when we talk about arrays, when we implemented the queue using arrays, then we saw there exists a fixed length of an array of or you can say a queue. Okay, let's suppose we have declare this queue, the size of the queue is 10, means it can contain maximum 10 elements. Now if we try to insert 11th element, it will create an error, okay, because we cannot insert any other data in the queue. It can contain maximum 10 elements. If we want to insert any other data, we will have to increase the size of the array. That's a lengthy process. When we are talking about linked list, there is no constraint like this. There exists no constraint of the size. So in case of linked list, overflow condition does not exist except for the case when there is no space in the memory. if you want to insert the data, if you want to enqueue some data in the queue, in that case you will check for overflow condition, otherwise you don't need to check this. Now if we write the code for this, okay, let's write the code for underflow condition. Underflow condition means if front is equals to null and rear is equals to null. अगर आप इनमें से एक भी कंडीशन चेक करोगे तो भी चलेगा, okay, because if f is null यानी कि front is null, then obviously the value of r would be null. In that case we can say there exists no element in the queue, so what we will do, we will just print a statement that is underflow condition. We cannot delete the data from the queue. In the same way, if we talk about the overflow condition, new node is equals to null, means there exists no space for new node also, okay. In that case what we will do, we will just print overflow condition. That is the main advantage of using linked list over array that we already have discussed, that there is no fixed size of the memory that you have to use. Let's talk about the enqueue function. Means you want to insert some data. So initially the value of front and the value of rear will be null, okay, and let's suppose you have created this node, the name of this node is new node, and the data is 10 and the next section contains null again. So first we will check, as we are enqueuing, we are inserting some data, so first we will check for overflow condition. If it does not exist, then we will enqueue the data, okay. In this case first we will check if f is equals to null, okay. Then what you have to do, you have to assign the address of this node in front and rear also, so that it can become the first node or the first data of the queue. So what we will write here, f is equals to new node and r is equals to new node. What will happen here, it will start containing 100 and both of them will start pointing to this node. Now our queue contains one element, that is 10. Now let's suppose you want to insert one more data, okay. So first it will check for f equals to null, this condition is false now, so it will go for else condition, it will execute else condition. So what we will do here, let's suppose now the new node is this one 20 and the address section contain null. So first you have to decide where this new node will be inserted, at the beginning of the linked list or at the end of the linked list. As we have discussed the concept of queue, rear always points to the last node that was inserted, okay. So we will insert this new node, always the new node will be inserted at the end of the linked list. So now the last node of the linked list is pointed by the rear. So what we will just do, we will write r dot next is equals to new node. Okay, so what will happen, let's suppose the address of the new node is 200, so now this section will start containing 200 and it will point to this, and next what we will have to do, r is equals to new node, and now r will start pointing to this node. That means this node has become the last node of the queue. That means our queue is 10 and then 20. Okay, means whenever you want to enqueue some data in a queue and you are implementing it using a linked list, you will insert the data at the end of the linked list. Okay, now if we talk about the dequeue of data, first we will check for underflow condition. If there is underflow condition, we will not delete any data here. So else, what we will write in else means there exists some data in the linked list in the queue. First you decide which data you will delete, front data or rear data. As we have discussed, we will delete the data from the front because front always point to the node or the element that is to be deleted next. Okay, so 10 is the element that is to be deleted. So what we will just write, f equals to f dot next. So what will happen, f will start pointing to the next node and this node will be deleted by itself. Okay, so this is all about the basics of the implementation of queue using linked list. Now let's implement it on Eclipse. So this is the basic structure of a program that we can implement using a linked list. It's same as we implemented it in case of stack. When we implemented stack using linked list, this same structure was used. Let me tell you what it is actually, what I have written here. So it's a class that is QLL, and I have implemented the main function in this class. I have created an object here for Q1 class. Q1 class, it's a class here. All the functions, that is Enqueue, Dequeue and display function, I'll create all these functions in this Q1 class. Okay, so I have just created an object here. Now I have implemented a do while loop here, so that compiler can ask the user for inserting the data again and again until he does not want to exit from the program. Okay, so press 1 to Enqueue, press 2 to Dequeue, 3 to display, enter your choice. Let's suppose the user enters 1, then Enqueue function will be executed, for 2 Dequeue function will be executed, and for 3 display function will be executed. So this is the basic concept of do while loop. I think I do not need to repeat it again and again. So now come to this class Q. So in this I have implemented a node class. All this we already have implemented and studied in the previous videos when we studied linked list. Okay, the link to all the videos is given in description box below. If you want to study it again, you can refer all those videos. So what this class is just doing, it will create, when you execute the program, it will create a node that contains data section and next section. Next section will contain the null, and data section will contain the data that user will provide. Okay, and we have taken 2 pointers here, front and rear, whose initial value is null. Now let's come to the Enqueue function. So first we will ask for the data from the user. So enter the data. I have created the object for this class, that is node class, and the data that user will insert will be passed from this class to this class. Okay, so now let's check for the condition. If I am writing the same code that I already have written in that paper, this one. Okay, so I am writing the same code. So if f is equals to null, that means there exists no element in the queue. So in that case, what you have to do, you will assign the value of new node in front and rear pointer both. So we will write f equals to new node, and that means, else means there exists some data, there exists already some data in the queue. So in that case, what we will do, we will insert the data at the end of the linked list. So we will write r dot next is equals to new node, and r is equals to new node. So this is all about this Enqueue function. Now let's come to this Dequeue function. So first we will check for underflow condition. If f is equals to null, in that case we cannot delete any data, so we will just print a statement here, system.out.print underflow condition, else we will write f equals to f dot next. That's all. Now come to the display function. Display function is same as we implemented in case of linked list. So this is the code for display function. We have taken a pointer of type node that is pointing to the front node. The temp pointer will move to the next nodes until the value of temp is not equals to null, and we will keep printing the value of temp dot data. So that this is all about this program. So now let's execute it. Control F11, enter 1, enter data 10, 0, press 1 again, 20, 0, 3, sorry, I have pressed 3, that is for display. Okay, so it has displayed 10 and 20 because I have inserted 10 and 20 only. Okay, now let's suppose I want to dequeue some data, so I will press 2, so it will delete 10 from the queue because front was pointing to the 10, so 10 will be deleted. So now if I display the data, so okay, so here you can see only 20 is here in the queue. Okay, so in this way you can implement queue using linked list. So if now we talk about the time complexity of queue. So first let's talk about Enqueue function. So in case of arrays, what we were just doing, we were just inserting the data at the end of the array. Okay, so in case of array, if you want to insert the data or you want to delete the data, it takes only big O of 1 time. So the array, in case of array, the time complexity would be big O of 1. And if we talk about the linked list, So in case of Enqueue, we are just inserting the data at the end of the linked list, okay, and we do not need to traverse all the elements because we have rear as a pointer there. So it also will take big O of 1. Dequeue data, we are just dequeuing the data from the front of the queue, so it will also take big O of 1 time. Now if you talk about display, so it will take big O of n because we will have to traverse one by one. Each element we will have to traverse one by one, so it will take big O of n. So in case of queue, you can use any of them, but because the main disadvantage of using array is you will have to fix the size of the array, fix the size of the queue at the starting of the program itself. So if you go with the linked list, that would be a great decision for you. Okay guys, I hope this video is going to help you a lot. If you like the video, don't forget to subscribe the channel and hit the bell icon. And if you have any query, you can ask in comment section below. So thank you. Good luck.